In the next two problems, we will use the squeeze theorem to solve the limit problem, to solve the sequence problem. So the squeeze theorem says that if we have sequences where the terms satisfy this condition, and a small remark that we don't need to satisfy this condition starting from n equals 1. So if this inequality holds true, okay, I should put a little more, for n greater than some number, some specific number, then that's enough. And also the second remark is that this inequality doesn't need to be less or equal. It can also be a strict inequality. Okay, so let me repeat again. If we have the following inequality for n greater than some number, and also we have the limit of the left sequence equals to the limit of the right sequence and equals to some number L, then the limit of the middle sequence also equals to L. Okay, let us apply this squeeze theorem to the following problem. So here we have sine 2n over 1 plus square root of n. In the setup of the squeeze theorem, so we want this to be our b sub n. Hence, we need to find the suitable a sub n and c sub n. Okay, how do we find that? Remember that sine x is always between -1 and 1. So note that -1, then sine twice of n is between -1 and 1. Therefore, we have the following inequality. So if divide all of them by 1 over square root of n, then we have the following inequality: -1 over 1 plus square root of n less than sine twice of n divided by 1 plus square root of n less or equal to 1 over 1 plus square root of n. Okay, so now this acts as our a sub n, then this acts as our c sub n. Now we observe that the limit as n approaches infinity, okay, let this as a sub n of a sub n. So when n approaches infinity, this is getting bigger and bigger. So the whole thing is getting smaller and smaller, approaches 0. And also the limit of the right hand side of c sub n, so this getting bigger and bigger, so the whole thing is getting smaller and smaller, approaches 0. So the limit of, since the limit of a sub n equals the limit of c sub n, which is 0, then we conclude that the limit of the middle sequence must be equal to 0 too. So therefore, by the squeeze theorem, the limit of n approaches infinity of the middle sequence sine twice of n over 1 plus square root of n is equal to 0. Okay, now the next problem, this will be a little bit more complicated. Okay, here we have the following a sub n. Okay, in this problem I can only demonstrate how to solve this without giving the idea how did I get the inequality. It is so the process of getting an inequality is some kind of a guesswork. Okay, so which is not everything is not tell on the paper. Okay, so let us see here. First, observe that 5, okay, can be written as 5 to the n. Okay, this is exactly the same thing, 5. I rewrite in this form just to make us easier to see that this expression is clearly less than this expression, than a sub n. Why this one is bigger than that? Because we add something more inside the square, inside the n square root. So certainly this one is bigger than 5. Okay, and now this is also, this guy, this a sub n, smaller than n square root of 5 sub n plus 5 sub n. Why? Because 3 sub n, 3 to the nth is less than 5 to the n. So certainly this inequality holds true. And if I simplify this, this is equal to 2 times 5 to the n 1 over n, which is equal to 1 over n times 5. Okay. Okay, now let us simplify the inequality. So from the above, we have 5 less or equal to a sub n, which is this guy, and a sub n is less or equal to 2 to the power of 1 over n times 5. So now our objective is to apply the squeeze theorem to this inequality. So we need to compute the limit of the left sequence, because it is a constant sequence, then the limit is 5. Now the limit of the right sequence, so again we can use the continuity, so it is equal to 2 to the power of the limit as n approaches infinity of 1 over n times 5. So as n approaches infinity, this 1 over n goes to 0. So 2 to the 0 times 5. But 2 to the 0 is 1. So 1 times 5 is 5. So from this computation, we know that the limit of the left sequence is equal to the limit of the right sequence, which is equal to 5. Then, by the squeeze theorem, we conclude that the limit of the middle sequence, which is the limit of a sub n, is equal to 5. And we are done.